Okay, we are going to. That's right, the real applications.
There's also a C and a D. This is the one where
Yeah, we take 2 days, it's okay. We're going to talk about some applications of exponentials. So, yesterday we went over graphing them, right? Basic, the mathematics of it. We'll talk a little bit more about applicational aspects of it. So I had 3 problems. I just couldn't get the pictures to size down enough for it to work. So, anybody in here in physics? You heard of Newton's law of cooling?
I've heard that.
Newton's law of cooling. Nope. No, not yet. Okay. Newton's law of cooling is the application of exponentials. Okay. So,
Why are you bringing science into this?
Math and science always end up together.
that's pretty useless without applications, right? So, now some things I'd let you just slide by doing the math only. There's some things where we have to learn the math and get to the applications. You guys are all at the point where you can start to apply your math a lot more. Then you get into calculus, and it gets even better. For statistics, why? Right? So that's why we will start talking about this stuff a lot more. So Newton's law of cooling.
You're a smart person.
Let's, in some ways. Let's say a cup of coffee. You guys drink coffee, a lot of you.
Yeah.
Shame on you, first of all.
Shame on you, first off.
Do you drink coffee?
It's 95 degrees centigrade. And yes, we're in science now, so we like the metric system. Okay.
Is that same for Celsius?
Same thing. Do you know how hot that is?
That is really hot.
It's pretty darn close to boiling, right? Boiling 100 centigrades. The room it's in is 20 degrees centigrade, so obviously that cup is going to cool, right?
Yeah.
Okay. The exponential equation that would model this situation.
Wait, what the heck is coming in that? It's going to become equilibrium.
20 in Fahrenheit terms. Basically, you can double it and add 32, so that's right around 72 degrees. It's a beautiful intervention. Okay, so here's the exponential that would model that cooling situation over time. Okay, you're going to see a lot of times we're going to start using t instead of x. It doesn't change anything for you except the letter. Okay. Call it a spelling error. Thank you. Yes, ma'am.
So, is there a reason why it's 75 and 0.635? Or are those just the numbers that sometimes?
Repeat that.
Where did you get 0.8?
What? Yeah, why do we have 70? Why just specific numbers? Just because of the science system, or is there like?
Well,
Or is it just like?
this is how this situation would be modeled by an exponential. So there would be a starting point for the temperature, and then this is the rate of decay, or of cooling, right? See how this is under 1, right? So this is a cooling situation or a decay situation.
So is it the-
Now we could probably take you through the whole reason that this is what it is. I don't know. Yeah, so this is the amount of cooling over t minutes. So if I put a time in here, calculate the value, that's going to tell me how much the coffee's cooled. So a question I can ask, how much, or, what's that? Let's see if I can- What is the temperature of the coffee at 15 minutes?
degrees Celsius.
Wow, you are smart. How'd you do that?
I took 0.875 to the 15th, or to the 15th power and multiplied it by 75.
Right, so you plug 15 in, and you, what do you get in?
10.12.
Okay, that's how much it's cooled, correct? So what is the temperature?
Oh.
Answer the question.
It's 85 point, or it's 84 point, like, 88.
95 minus 10.12 is
84.88.
there you go. We're in America, so we have to do that. So, right. A real basic application, but it is good. You know, if you're headed to a science career, you gotta start somewhere. Let's get you going. Okay.
Wait, where
Did it
did
say
you get
95
15?
after 10?
Oh.
Did it say 95 minus 10?
Yes. Can you graph this equation? Could you?
No.
Why not?
Yeah.
Because I don't know how.
I told you yesterday how.
Tan equal to X.
I showed you yesterday how to graph equations.
It wouldn't be a scale.
I mean, I can like draw a line on the graph later.
So we have this, right? So obviously those numbers are not pretty, so the best way to do this is either with table values or a calculator, right? What if the time is 0?
It'd be nice
Not according to the equation.
Well, where's
know.
the T? T's that little thing right there. with some-
T's this.
Oh, I thought that was.
If t is 0, the equation tells us that it's 75. Okay, I don't know why they did that. Very good. Okay, what if t is 1?
So,
0.875, right? Anybody know that?
And this calculates out of the percent of this.
That's probably.
No.
6.565.
Yeah,
66.565.
I got 65.
6. 6.5.
No, that's 65.
That doesn't make sense at all.
Oh, I didn't put it in there. So you get 60.
It's 65.
66.5.
Okay, well, we are gonna graph that accurately. at
It's
least, but
65.65.
Yeah.
Check your typing. Okay, so what you see obviously is the trend.
So that.
Is it ever gonna go below 20?
No. Yeah, eventually. Won't it? Couldn't the room like change temperature?
Ah, but see, if the room change temperatures, it can go lower, right?
Yeah.
But if the room stays at 20, is it ever gonna go below 20?
No.
That's the.
Will it match the room temperature?
No.
Yeah.
It eventually would, so, so in reality, mathematically, there's a horizontal asymptote of 20, right? But in reality, you're probably gonna have 20-degree coffee here in a few hours. Right, so you gotta think through these a little bit.
Wait, won't it get colder than the room?
No.
Oh my
Not
God.
possible.
Isn't it the same thing as
Check
something
it.
cold?
I'm gonna guess, honestly, there's a typo. To be
Maybe then
honest.
it's like 95?
Right, so, we're just gonna go with it. I don't, it doesn't make sense to me. If I were writing this problem, I would have put 95 right there. There you go. Okay, next. There is. Okay, this is an equation that can model exponential growth or decay. Well, in general, if you have to write,
Is that just subset zero?
yeah, it's a sub-zero.
Is that ITR? Or 1TR in?
That's not a bad thought, actually.
Yeah, that's what I was thinking.
Okay, n equals n subscript 0, n sub 0,
Oh.
times 1 plus r to the t. Okay, n0 is your initial value. That would have been our 95-degree copy. And r is your rate, whether it's growth or decay. Yeah, t is times. We could all wish and hope.
Wow.
Wow.
That wasn't even funny.
No, that was funny.
I didn't mean to.
All right, so here's a situation. Would you rather talk about beekeeping or bacteria growth?
Beekeeping.
Okay, how many bees are we going to start with?
10, 70 million. 10 bees.
70.
75 bees. 117.
Okay, let's start with 100. I'm trying to like average all these numbers above my head. Okay, you got to start with a certain number for a colony to survive, right? So let's start with 100 bees. Okay, we're going to have a rate of growth of 10% per week.
I think, every week they're gonna gain 10.
That means the first week they'll gain 10.
And then from there.
Second week they'll gain
Like 20.
11. Because there will be 110 of them, 10% of that's 11. This is the, okay, exponential growth, there you go. How many bees are there after 20 weeks? Now here's the beauty of exponentials. In the past, you would have to go through and calculate every single week. 20 different times, right?
Yeah.
Right, so you have to say, oh, week 0 is 100, now week 1 there's 110. Week 2 there will be 121, and you'd have to, okay. Here's the nice thing about this problem. What's our initial value?
100.
100. 1 plus 0, yes, 0.1. And then our time is 20 weeks. So now you do one calculation, you have your answer. Okay, so 1.1 to the 20th times 100.
1.1.
You need 20 bees.
That's
to know
gonna be
that-
172.
You need 20 bees to know what that changes already.
David,
673.
anybody disagree?
Because it's 0.74, you can have 0.74 of a B.
0.75.
Sure you can.
You can have 0.75 of a B. So
And
you
you want to eat his head off or something?
That's enough. We digress.
logically here.
Are we okay with this?
Yes.
Yeah.
Remember your order of operations. Parentheses first, exponents, multiply. Okay? There you go. Believe it or not, there's somebody in Colburn that has 100 bee colonies in his backyard. His backyard's on the side of that patch along right outside his club.
Hold on, Dee.
Okay, let's talk about finance a little bit.
Throwing this one out.
Okay, well, he doesn't have anything else.
He doesn't have anything else to do.
Okay. How many of you have a job?
I have 2 jobs.
Okay, so a few of you have a job. You earn money. Do you put any of that in the savings account?
No.
10%.
10%? No.
Oh, I have
No?
to change matters.
You do?
I do.
High five. Good. Okay, here's why you need to start saving as soon as you get a first job.
Interest.
Compound interest,
What's that mean?
okay? That means that this year, if you have put $100 in and the interest rate's 5%, right?
Oh my God, you have $500.
No.
Oh, wait.
The next year you have 105, right?
I'm an idiot. Oh my God.
The third year you have $110 and what's 5% of 5?
25.
It's 25 cents. So you are compounding interest on the interest. Now if you keep adding to that, it's going to continue to grow and grow. And after 30 or 40 years, this is going to be a much, much larger.
Wait, what if I put it in my savings account and then I need to get something done?
If you spend it, it doesn't earn interest anymore.
Yeah.
Okay? So that's compounded interest.
So
It's
you can let it
compounding
sit
on
there for a
itself.
whole year?
that's a
and
really
you
high
don't
percentage
spend
of
any of it?
5?
Or do you just take
For
it
a
out?
savings account right now it is.
Yeah, I'm gonna say, cause most,
Is it the amount you have at the end of the year, or is it like it has to go a year and you can't touch it at all?
That would be if you didn't take anything out or put anything in.
Oh my God.
So what's the
How are
amount
you
that
supposed to
Where's
be
to your
saving without
advantage?
putting more in there?
No,
You just make lots of savings.
He's saying this is
It's
the
your advantage
example
to
he's using.
put it in there, leave it alone, and continue putting more in there.
But if you add, you don't get interest, you just say.
Now, if you add, it does give you interest. If you take it out, obviously, it's not going to be earning interest. Here's the formula for compound interest calculations. So this is going to take us away from doing, again, 1, 2, 3, 4, 5, 6, 7, okay? It's R over N. Okay, it's the same. Shh. Ah. That's not a palace. Okay, that's your initial amount, just like the last equation. You still have a 1 just like the last equation. R is going to be 8. Okay, you notice the similarities here.
So what's N equal
Okay, N is the number of times per year interest is compounded or calculated.
to? That's to the power of N.
So, let's say there are 12 months a year, and once a month the bank calculates your interest, right? What would N be? 12, right? 12 times per year.
And then wouldn't it be 12 as well?
T is the time that you want to calculate how much you have.
yeah, I remember that.
Okay. So let's start with, this is a very basic example because it does not involve us adding any money to this account at all. Okay, so we're going to start with, let's say $2,000. Okay, and then our interest rate, 3%. right now, interest rates for savings accounts are like 0.1 and 0.2%. Terrible. Historically, 2 to 3% is probably somewhere in the average. How much time do you want to calculate?
A year.
No, 17 years.
Let's go long term.
30. 50.
You leave that in account alone at 3% over 20 years, how much is it gonna have in it? And we're gonna compound it monthly. Ooh.
So it'd be compounded
Yeah,
240
so
times.
that means that n equals 12. Good call. So we'll log and chug now. 1 plus 0.03 over. Now remember, interest percentages have to be decimals.
And that's 240.
Got to see what compounding does for you. To the 240th power. Pretty good deal, right? Alright, so this is your calculation. You have compound it monthly, you have your interest rate, and your time period, and your initial principal.
How many times does 0.3 go to 12? 12
Well,
rounds.
they were just more.
0.25. Anybody?
$1,641.
Oh, my calculator can't do that.
You've almost doubled your money just letting it sit there. You have done nothing except let it sit
Okay, if I
there.
put like 20.
It's like earning money doing nothing. It's a good deal, right? Now imagine adding $100 a month to that. It's gonna add up, right?
So how would you represent that equation?
Adding money to your account.
So
Is that what you do?
yeah, so it'd be like 2,000 less 100.
So why don't you just do the normal equation and add 100 to it? If you're,
I tell you what I would do is I'd make an Excel spreadsheet, and I just drag my rows down and do the calculation. Yeah, these are very basic because it doesn't allow for you to add money to your account. So, but again, it gives you an idea of what saving money can do for you, right? Questions? These are word problems. You have to pull the info out and put it in the right equation. Okay? I would think spring break should start tomorrow the way some of you are acting.
I wish it would start tomorrow.
Yeah, it's supposed to be minutes.
Is today the first week back?
Yeah.
Holy crap, it feels like the last day of school.
No, you better than that.
Switch to a piece of gum. They're trading a piece of gum. Either it was,
We're
or
gonna
trading
take
it
this
used.
class whatsoever.
Yeah.
This is the gum I give to people when they ask if I have gum.
What's that?
There you go.
That's 16 through 25?
No. There's a column. About 5 minutes.
And are they all word problems?
That's a good question.
Do you just choose random problems?
No, they're very purposefully chosen. The 8 and 9 are word problems. 10 is not. 12 is not. 16 is not. 25 and 31 are. So about half of them are word problems.
How is 12 not? Oh, never mind.
Sorry. Sometimes I choose the
Maybe Sophie was just confused though, because that's what
That would usually be because I make change here to get in class, and I don't change the assignment. Okay. We're better today. Not saying much,
I told you that.
but check it Tuesday. Maybe we should define that. So we're on the same page. I could probably do that right now, Alexis, to one of you.
Not me though.
You're not the only person in the world that matters.
Oh, I'm
I know, it looks like it. Straight up. So, you need to play basketball.
No, basketball breaks your back. Oh, but,
Is that how you broke your back?
yeah, I think.
Playing basketball?
Yeah, like we could have a lawsuit against like,
But we don't have proof, so.
Yeah, that'll probably not come out in the victory then.
we could have a lawsuit against the hospital too, considering they told me I had kidney stones for a whole year when I actually broke my back and my spine was just like hurt.
That's a really crappy outfit.
Yeah.
Was that right?
Are you fumbling stuff out? Is that here?
Mhm.
Did they x-ray it?
Not the first time. He was like, yeah, it's kidney stones. He sent me to a specialist, and specialist was like, no, you're good. And I still had pain, but no one really cared. And then we went back in and I went to a different doctor and he was like, oh yeah, bend over. And I bent over and he was like, oh, your spine's all crooked. And he took x-rays because 3 of my vertebrae just like shifted over and were like leaned against my spinal cord because, so I couldn't feel my legs when I would run and stuff. And I was like, tell Coach Edgar, I was like, I can't feel my legs when I go fast. And he was like, you're on JV. It's super stupid. Yeah, that's funny.
Where was that?
This season.
This year.
But I broke it last year. So it was broken for a whole year. So I got like scoliosis and stuff from being
Heal now?
It doesn't heal. Like you can see like a little crack in all my vertebrae when you like
Wrong with
strain
it?
me.
Heal.
No, your spine.
Your spine doesn't. It just
Your
like
spine
deposits
goes forward
calcium
and
in like a little crack.
vertebrae.
So like if you x-ray me right now, you can still see that it was like broken at one point. But it's straight now, so they let me play soccer.
There's no bone growth to support the cracks or
It's just calcium deposits.
it's bone.
Did they not put any rods in?
No, I needed surgery, but I was only 16 when I broke it, so they wanted to let me such a young age.
Where were you playing basketball when that happened?
Practice. We're allowed to
Here?
just like beat each other up to be
Yeah, we are allowed to beat each other.
Can I come?
Okay, no, you should just be like Eric playing UCLA. He's sure he doesn't even care. He landed on me. Yeah, he doesn't.
I believe it. No, I believe it. That's kind
It's
of
fun,
crazy.
though. Like it would be boring if we weren't allowed to, because it's a little dangerous.
Still living, I broke my back.
Yeah, I have compound fractures too, and usually you only get those from like really bad marbles and stuff. They like them for basketball.
Do you know when it could have happened?
There was a day when one of these older girls like shoved me because like she like shoved me down and then like jumped all over me. It was just like really unnecessary and I went to run up to my mom with my back hurt and stuff and she was like, oh, we'll give it a day for this and I just was complaining about it. She was like, yeah, you're good. And I actually broke my spine.
Yeah. Leave your assignments on there. We'll pick it up. Pretty good around here.
Let me have your looks. See you, Arthur.
Bye.
It's okay. We have a freshman team, so. Oh. You guys are bad. I feel like the last one was too bad.
I need a re-lesson.
I doubt
Considering
it.
that I didn't get any of the notes, I feel like I did fairly well. But
What I forgot to tell you about the difference between the book problems and the one you were
Yeah,
gonna
I was
see.
very confused.
Once you said that the y prime is equal to the same as d by 3x, that helped me so much.
Right, and that's, yeah, I just forgot to say something. That was
What
fine.
changes